Hi guys, Angad here and welcome back to another video. So today I'm going to be talking about addition of vectors. Some people really do tend to struggle with this topic, and to be completely honest with you, in the beginning I did too. But once I found out about this method, everything was pitch clear for me. So I thought let me share this method with you guys. Now there are many laws for addition of vectors like the triangle law of vectors or parallelogram law of vectors, but the method I'm about to teach you guys doesn't require any of these laws and works for all shapes. This method has a weird name though. As you can see, it's called the head to tail method. Now I know you might be very confused, but hold on your horses as I'm about to explain it in just a second. But before we start, there are some things to keep in mind. So we can't add vectors mathematically like numbers, as they have direction in them as well. And when we want to add vectors, we will have to keep in mind their direction as well. The first and the second point basically mean the same thing, that we can't just add vectors, their units, because they also have direction. We need to keep in mind their direction as well. There are also some things we need to assume about vectors. Any vector can be treated as an arrow with a tail and a head, so it can be treated as an arrow like this. The direction of the vector is the same as the direction shown by the arrowhead, like this over here. So for this arrow, the direction will be east. The size and magnitude of the vector is equal to the length of the arrow. So like this length over here, supposing this is 5 centimeters, this 5 signifies the size of the vector, and the vector remains unchanged as long as its length and direction is not changed. So if I draw this vector, suppose say here, it's still 5 centimeters, and the direction is still of the arrowhead is still the same. The vector remains unchanged. Okay, so now that we have talked about the important notes and the assumptions, let me just tell you the quick definition. So in the head to tail method, you need to align the tail of the second vector to the head of the first vector, and while doing so, you need to make sure that the way the vectors are positioned, their length and their direction remains the same. You don't mess with that. Resultant of addition is given by joining the tail of the first vector to the head of the second vector with the help of a line. The length of the resultant arrow will give us the magnitude, and the resultant vector and the direction of the resultant vector is at theta angle ACW from a vector. So let me just explain this a bit. So supposing that you have a vector like this and another vector like this over here. So to add these two vectors, you first align this vector. This is supposing one vector, first vector, second vector. You take the first vector's tail and attach it to the second vector's head, while making sure that the length, supposing it's 5, 4 over here, length remains the same, and also the direction remains the same. Okay, then you draw a line that connects the tail of the second vector to the head of the first vector. It will be like this, and this will be facing here. Okay, so since this is at a 90-degree angle, we can use the Pythagoras theorem, which is a square plus b square is equal to c square, to find out the size of this vector. And to find out the angle, we can just use a protractor and find out the angle respective to this second vector. Okay, so if this was not a 90-degree angle, suppose say this was a 70-degree angle, then all you need to do is you need to find a relation between this magnitude of the second vector and the length of it, and use that same and see if that relation matches with the magnitude of the first vector and the length of it. Then you can use that same relation to find the magnitude of the of the resultant vector. Let me give another example so it's crystal clear for you guys. Supposing you have a vector that's like this, one, let me just name it A, this is x centimeters. Another vector like this, let me name this B, this is y centimeters. Another vector like this, let me name this C, this is z centimeters. is there are three vectors now. So first we attach the tail we attach the tail of the y vector to the head of tail of the b vector to the head of the c vector like this. We make sure that the direction and the size remains the same. Okay, and then we attach the tail of the a vector to the tail of the b vector, to the head of the b vector, like this. We need to make sure that the size and the direction remains the same. Sorry if my drawing is like that, but it should be the same. Then you just draw a line that connects the head of the a vector to the tail of the c vector, like this. I'll be facing that direction. Okay, so now if you need to find the angle, the direction, so you can just find this angle using a protractor, and resultant vectors at an angle this can anything theta angle from vector c, and then you can find the length of this vector by just taking in the relations as I talked about earlier for each of these vectors and corresponding it with their length. So this is a much simpler method, I believe, for finding the addition of vectors, or just, and you don't have to remember any of the triangle laws or parallelogram laws. All you need to do is remember this head to tail method. If you know that, I believe it will be very easy for you to add any vectors in the future. That's all for today. Thank you. Please make sure to subscribe below and hit the like button. If you have any questions, put it down in the comment section below. I will be answering to those. And yeah, please do let me know if you're struggling with any kind of topic. I will cover that in the future video. Thank you.